Welcome to this explainer. Today, we're pulling back the curtain on artificial intelligence to look at something that, honestly, keeps a lot of developers up at night. We're talking about quantifying trust in neural data systems. Since pretty much all of us rely on AI these days, understanding its hidden mechanics and its structural vulnerabilities is absolutely crucial. We're going to break down exactly what goes into these models and why the shiny surface level rarely tells the whole story. Okay, so to really grasp this vulnerability, let's first talk about the sheer grueling timeline of getting a dataset off the ground. It is a massive grind. First, you've got months and months of just building the architecture. Then you have literal armies of annotators turning out thousands of labels, probably fueled by way too much coffee. And then come the endless, exhausting review cycles to check all that work. Throw in the millions of dollars invested, and well, it's a remarkably heavy lift just to get to the starting line. But let's say you get through all that. The model finally performs. The metrics are looking strong, leadership happily gives the green light for deployment, and the whole team takes a well-deserved victory lap. It's this beautiful picture of technological triumph, right? Everyone in the room feels perfectly secure. They're completely caught up in the hype of seeing green across the board, just assuming the hard part is finally over. And then the music stops. All of that amazing forward momentum just hits a brick wall when someone at the table asks one single, extremely dangerous question. How reliable is the data underneath all this? Seriously, crickets. That is exactly where most development teams just freeze. The celebration goes completely silent. And why? Because traditional datasets are basically just flat collections of files. They completely lack the built-in tracking or metadata to tell you how reliable they actually are. They aren't built to quantify trust at all. They're just built to act as a giant storage bin for data. It's a massive structural blind spot sitting right at the very foundation of the technology. And here is where we hit the fatal flaw in that traditional system. Think about how the inputs are actually handled. On one hand, you might have a meticulously verified fact from a domain expert, like, say, a trained cardiologist correctly spotting an anomaly on an ECG. But on the other hand, you've got a total wild guess from some rushed annotator just trying to hit their daily quota. The crazy part? The system treats them as exact equals. During training, a careless guess carries the exact same weight as a verified truth. The algorithm literally has no idea who was guessing and who actually knew the answer. So what does this all mean? It means that while those deployment metrics we talked about earlier might look incredibly pristine on the surface, there are massive, dangerous layers of uncertainty buried deep within the system. It's a structural weakness hiding in plain sight. And this matters to us because the next time an AI hallucinates a completely fake legal case or misidentifies a critical medical image, well, this buried uncertainty is very often the root cause. So how do we fix it? Well, this brings us to a tool that's actively trying to shatter this whole illusion, Codatta.io. Instead of just crossing our fingers and letting that uncertainty remain buried, this system introduces actual mechanics to quantify data trust. By evaluating the source, tracking the metadata, and analyzing the consensus of the inputs, it gives developers a structured, mathematical way to measure the reliability of their model's foundation. Basically, it digs up that hidden uncertainty and finally puts a real number on it. You can almost think of it like generating a topographical map, but for data trust. First, it pinpoints the bedrock, showing you exactly where confidence is strongest, so you know what parts of the model are rock solid. Second, it exposes the fault lines, highlighting exactly where those rushed guesses and deep uncertainties are hiding. And finally, it tells teams exactly where they need to target their validation resources to fix the foundation well before massive public failure happens. Which really leaves us with a provocative thought about the AI tools we interact with every single day. Are the datasets powering them just static collections of files, or are they living systems of measurable trust? Knowing the dangerous uncertainties buried in traditional models, we really can't settle for the illusion of success anymore. We need systems that prove their reliability from the ground up.